Structure and properties of ionic compounds. So ionic compounds, things like sodium chloride, sodium oxide, potassium chloride, potassium sulfide, they have giant ionic lattice structures. If we go back to our flow chart, so we're down this green pen section, when we have a metal with a non-metal, our bonding is called ionic and our structure is called giant ionic lattice. So if the exam board asks us to describe the structure and the bonding, we need to make sure that we do just that. We say that it is ionic bonding in a giant ionic lattice structure, and our particles are being held together by strong electrostatic attractions between oppositely charged ions. So if we were to just make a little note of that, so we have our structure for this page is giant ionic lattice. Our bonding is ionic. And our forces, when we come to questions about forces, is strong, electrostatic attractions, very important, attractions between oppositely charged ions. Okay, so we drew in an earlier lesson that structure of a giant ionic lattice. So the giant ionic lattice, we said, is held together by strong electrostatic forces of attraction. You can't just say forces, it must be of attraction between oppositely charged ions. So why do they have a high melting point? So they have a high melting point because it takes a lot of energy. To overcome strong forces of attraction between oppositely charged ions. Why then do they conduct, or when do they conduct? So do they conduct when they're solid? No. Ionic solids do not conduct. Why not? The ions are fixed in position in the lattice. There are no delocalized electrons in something ionic, and the ions are fixed in the lattice, so cannot move, and therefore do not carry charge. But when we dissolve them or melt them, the ions become free to move. And carry current or carry charge. So molten or dissolved ionic substances conduct. What about if I were to hit my ionic solid with a hammer? What happens, if you can see from this diagram, is if I hit it here with a hammer, I push down this positive ion and it becomes in line with this other positive ion, and then those two are pushed apart by repulsive forces because like charges repel. So the like charges will move next to each other and cause the lattice structure to fly apart. So ionic substances are brittle. We could also think about their solubility. Because these ions are charged, ionic substances are soluble, generally soluble in water, because the positive and negative parts of water, the dipoles, will be attracted to the ions. Positive ions attract delta minus oxygen in H2O. Negative ions attract the delta plus hydrogen in H2O.